Here we go. Sorry, I'm going to start at the beginning. Here we go. Quadratic applications. The drawing below represents the path of an object in vertical motion. So they've given us a picture of what's happening. Ground is at 0 for height. The path of the ball that is kicked upwards can be described by the equation h equals 35t minus 5t squared, where h is the height of the ball in meters and t is the time in seconds. So we've already said that we're letting h equal t height and t equal time. We are starting to answer the question, how high is the ball after 3 seconds? So we have been given t equals 3 and we need to solve for h. So we are plugging 3 in for t. And now we've got h is equal to, well, 35 times 3 is 105. And minus 5 times 3 squared, and you can do that very easily in your calculator. I would make sure your 3 is in parentheses. So you've got 5 parentheses 3 parentheses squared, and you hit enter, and we find out that it's 45. So h is 60 meters. That is how high the ball is after 3 seconds. Okay. After how many seconds will the ball be 50 meters high? So now they're wanting to know how many seconds. So they're wanting you to solve for t. So they're wanting to know what t is when h is 50. Okay. So we have the same equation. H is equal to 35t minus 5t squared, and here we're just going to substitute what they've given us for h and solve for t. So we've got 50 is equal to 35t minus 5t squared. I want to get my t squared positive. Okay, so what I'm going to do is swap these. And you know when you swap these, well, I'm going to bring this so that I have my quadratic equation all together and have it equal to 0 is what I'm really going to do. Okay, so I'm going to subtract 35t and I'm going to add 5t squared to this side, which just makes this side 0, doesn't it? And I'm going to do the same thing on this side. I'm going to subtract 35t and add 5t squared. Now, I'm going to swap these out so it looks better. It looks more like what we're used to seeing. 5t squared minus 35t plus 50 is equal to 0. So what tools do I have without the calculator, because you're going to show your work, what tools do I have to solve this? I'm waiting. I'm going to wait you out. You need to think, how do you solve quadratic equations?
Formulas.
And to me, the go-to is your quadratic formula, because that works for everything. You don't know if completing the square is going to work. You don't know if your other ways to solve a quadratic are going to work, and you're going to need to show your work. When you get to a STAR test, I could care less if you show your work, all right? But for class, you are going to show your work, because I still say you've got to get good at this, because when you take college algebra, you take algebra 2, they're going to expect you to show your work. Even on a test, all my professors in college expected to show your work. You couldn't just put something in a calculator and get an answer. If you did, you didn't get the answer right, or they took off points. And I'm sorry, it's blurry at the second. For some reason, because I had it covering up over here. All right, so I guess I'm going to have to do this. All right, so when will the ball hit the ground? Oh, no, we're on this one. We're going to solve it by quadratic equation, which is subtract b plus or minus the square root of b squared in parentheses, right? Your b's in parentheses, minus 4ac, and everything is over 2a. So my a value here for this equation is 5. My b value is negative 35. My c value is 50. And here we go. So I've got a negative 35 plus or minus the square root of negative 35 squared minus 4 times 5 times 50. Okay. All over 2 times 5. Sorry, I wrote an A. I should be writing a 5. Okay. Alright, so I'm going to clean up what I have. I am going to take some shortcuts. I know that negative 35, and this is going to give me a positive 35, plus or minus the square root. And I'm going to do all this whole thing under my square root in one shot in my calculator. So I'm going to do parentheses, negative 35 parentheses squared, subtract 4 parentheses 5 parentheses 50 parentheses, and I'm going to clean up everything in one calculation underneath that square root symbol. And it comes out to 225, which happens to be a perfect square. Isn't that cool? And then 2 times 5 is 10. Okay? So I'm going to take the shorter root here, the square root of 225. Does anybody know it off the top of their head? It's 15. Okay? Alright? So we've got 35 plus 15 over 10, or 35 minus 15 over 10, don't we? And that's how I'm just going to take that one shortcut. Okay? So if I do 35 plus 15, I get what? 50. Divided by 10 is 5. So x is either equal to 5, or 35 minus 15 is what? 20. Okay, 20 divided by 10 is x is equal to 2. So my two answer choices here, which are both possible, and why is it possible that I can have two answer choices for time? Think about the problem. What did we do? We threw a ball, didn't we? We threw an object from the ground. We'll just say it was a ball, and we threw it up, and then we threw it back down. So 2 seconds is going to obviously be over here, isn't it? Does that make sense to you? And 5, because at 2 seconds it's going to be here, and at 5 seconds it's going to be here, because it's going to be the later on the other side as it's coming back down. Remember, a parabola is always going to hit that same y or x value at the same, twice, okay? So x is equal to, or h is equal to 2 seconds and 5 seconds. We can have two answers that make perfect sense for our scenario, okay? With this, when you're talking about real life problems, you have to make sure that your answers are making sense. Okay, if we had gotten a negative number, would that make sense? Because can you have negative time? No, not in this lifetime, at least not yet. I mean, at some point maybe, if you can time travel. And that's the ooh, isn't that interesting, huh? Then you could go back and you would have negative time in problems if you were time traveling. Really cool. See all these kinds of things you can apply this to? It's pretty cool. Okay, when will the ball hit the ground? So now, okay, so let's write our original. H is equal to 35t minus 5t squared. All right, remember we have when, so they're wanting to solve for t what is the height of this object when it hits the ground? 0. Right. So h, we know that h is 0. So now we can just plug in h, right? 0 for h. So 0 is now equal to 35t minus 5t squared. And when you have it this way, you can very easily solve this, okay, by setting both of your factors. You don't have to bring your 0 over and get it all on one side, because you still would be equal to 0, wouldn't you? You'd have 5t squared minus 35t plus 0 is equal to 0. So there's no reason to be doing all that, all right? So what we can do, though, and for some of you, working the equation this way is hard. So if you want to flip it and do it like this, where you would have 5t squared is equal to 0 or 35t is equal to 0, you can do that. Okay? Or we could factor, couldn't we? Wouldn't that even make it easier? Because what do 35 and 5 have in common? What? Well, they have what else in common? 5. So I can pull out a 5 and a t out of this and say 0 is equal to 5t times, because if I factor this, that's easier than going through the quadratic equation, because that's what I would have to do to get an answer, not doing what I just did on that piece of paper. Ignore that, okay? So that would be 7 minus t, wouldn't it? Now I have two factors of quadratic equation. So we can then do 5t is equal to 0, or 0 is equal to 7 minus t, can't we? Okay. So if you have 5t is equal to 0 or 7 minus t is equal to 0, well, I'm going to rewrite that up here so that I have some room to work, and 0 is equal to 7 minus t. If I divide both sides by 5, t is either equal to 0, and here, what would I do? I can add my t to both sides, and I've got t is equal to 7, because I can't leave a negative t, okay? So, tell me, in this situation, which one makes sense? When will the ball hit the ground? Why?
Because it means 0 seconds when it started.
Right, because 0 is back here when you started and you threw it, right? So it's not hitting the ground then, it's already at the ground level at 0 seconds. So 7 is going to be your answer, is when it's going to come back down and hit the ground right here. So it would be 7 seconds is your answer there. Okay? All right, let's look at the next question. Okay. An archer shoots an arrow into the air. The equation that describes the path of the arrow is h equals 7t minus 5t squared, where h is the height in meters and t is the time in seconds. So, at how high is the arrow? So we want to know what h is, and we know that t is equal to 2 after 2 seconds. So, h is equal to 17t minus 5t squared. Alright, so then we're just going to substitute because we know what t is. H is equal to 17 times 2 minus 5 times 2 squared. Okay. 17 times 2, h is equal to 34. 2 squared is 4. 4 times negative 5 is negative 20. So, h is equal to 14. So that is 14. And they say this is in meters. Meters. is going to be your answer. Okay? When will the arrow be at 10 meters high? So now they're talking about they want you to solve for t, and they've given you the arrow at 10 meters high. So I'm just h is equal to 17t minus 5t squared. So we've got 10 is equal to 17t minus 5t squared. I'm going to go ahead and bring my stuff over, and I'm going to do it without doing all the, so I've got 5t squared, now that's positive, minus 17t plus 10 is equal to 0. Okay? So what do we need to do to find this one? Use our quadratic formula, people, because 17 and 5 don't have anything, there's nothing in common here I can pull out, okay? So, I'm going to do, we've got A equals B equals C equals, and I've got A of 5, a B at negative 17, and C is 10, okay? So I'm going to solve this, and I'm going to do plus, oh, I got to get my formula chart out. My brain just went dead. Okay, I've got x, okay, so it's going to be minus b, which is minus 17 plus or minus the square root of b squared, so negative 17 squared minus 4 times 5 times 10 all over 2 times 5. So I've got a positive 17 there again. I'm going to do everything underneath that square root in one little swap here. I'm going to do parentheses negative 17 parentheses squared minus 4, parentheses 5, parentheses 10, and hit enter, and I get 89. That's interesting. Make sure I put it in right. Okay, so I get the plus or minus the square root of 89. What did I do? I did something, guys. We need to figure it out. Because 34 minus 20, because this should be a negative number, so what did I do? 17 squared, let's see, 17 times 17 is 289. I've done something wrong here. I put something wrong somewhere, and I'm not sure where. Where did I make my problem here? Because this should be 289, and then I'm going to subtract. This gives me negative 20 times 10. No, that's right. It's 289. What? No, because when I brought it over, it should be negative. It should change signs. In other words, when I brought them over, it should have changed my signs. And I'm trying to figure out what I'm doing wrong, and I should have got negative 17 squared minus 2, which is, okay, alright, I get it. what's the square root of 89? Sorry, second square root 89. It threw me because it wasn't a perfect square. So 9, 4, 3, 3, it looks like 9. So we're going to do this over 10, and 17 plus or minus the square root of 89 is, we're just going to make it 9.43, okay? And then we've got over 2 times 5, which is 10, I'm sorry. Sorry, my bad. I should know better. Okay. All right, so then I've got 17, and my pencil's running out of lead now. All right, let's try another one. 17 plus 9.43 over 10, or 17 minus 9.43 over 10. So I'm going to do this 17 plus 9.43, and then I'm going to divide that by 10, and I'm going to get 2.64 seconds, or 6 seconds, 2.6 seconds, and then 17 minus 9.43, 7.57 divided by 10 is 0.76 seconds, or 0.76, or you could round that to 0.8 seconds. So the question is, when will the arrow be at 10 meters high? Well, at 0.8 seconds, okay, and 2.6 seconds. And remember, this is where you would not want to leave things in fractions, because when you are talking about time, it's easier to talk about it in decimals. When you're talking about height, but you can leave it in fractions if you want. So if you get a not a perfect square under the radicals, still deal with it, okay? Just round it and get to something. Don't round this to a whole number until you get closer down in here, then round it to the closest decimal. And you know, if you're off a couple of few milliliters or a few tenths or whatever, I'm not going to count it wrong. I'm more concerned about, did you get it? All right. When will it be 20 meters high? All right. So same scenario, only now h is 20. So I've got h is equal to 17t minus 5t squared. I've got 20 is equal to 17t minus 5t squared. Okay. Kate, what you were saying earlier is because when I brought this over, I made it negative, but see, what I've done is I would subtract 17t here, add 5t squared here, so that I could bring it over to this side. Do you see what I did? Okay, so I'm going to do the same thing here. I've got 5t squared minus 17t plus 20 is equal to 0. And so I am going to plug that in now, I've got A is equal to 5, B is equal to negative 17, and C is equal to 20, and I've got X is equal to a negative 17 plus or minus the square root of negative 17 squared minus 4 times 5 times 20 all over 2 times 5. So I've got 17 plus or minus the square root of, now if I do this, parentheses, negative 17 parentheses squared minus 4 parentheses 5 parentheses 20 parentheses. What does that leave me under the square root? A negative. Is that something we can do? Negative 111. Therefore, as soon as I have this situation right here, that tells me that it will never happen. Okay? So when will it be 20 meters high? Never. Okay? Never, ever, ever. All right? It will not be, and this is my proof right here because I cannot do the square root of negative 111. Okay? So in other words, it never got that high when they threw it. When will it come back to the ground? All right, here we go. So, ground is what level? What's your number for ground? What's your height for ground? 0. Okay? So I'm going to just set this height is 0 is equal to 17t minus 5t squared. Okay? So what can I pull out of this now? What do they have in common? T, and I have 17 minus 5t, okay, is equal to 0. Now I have t is equal to 0, or I have 0 is equal to 17 minus 5t, correct? All right, I'm going to do a flip-flop, and I'm going to do 5t is equal to 17, divide both sides by 5, t is equal to 17 divided by 5, and I get 3.4. So, my two answers here, when will it come back to the ground? When is it going to come back to the ground? At 0 or at 3.4 seconds? 3.4 seconds, because it's left the ground at time 0. Okay? So my answer would be 3.4 seconds. And we might have time to shove this one in. A baseball is hit into the air. The path of the ball can be described by the equation. I probably will shorthand this for you. Okay? So you got the idea, you've got the pattern now that your questions are going to be in. All right, so h is equal to 23t minus 5t squared, where h is the height and t is your time. So if I have t is equal to 3, I'm just going to substitute, and I'm going to do h is equal to 23 times 3 minus 5 times 3 squared, and I am going to find out that h is equal to 24. So at 24 meters, the ball will be at 24 meters at 3 seconds. Okay? When will the ball be 19 meters high? So now we've got h is equal to 19. This is where you're going to have to do a quadratic. So you've got 19 of the formula. They're all quadratics. I don't mean to say that they're not. Okay? Or I'm going to end up with 5t squared minus 2t plus 19 is equal to 0. If I plug it in, and I'm going to shorthand this, x is equal to 23, because my this is a 23 here, not a 2, isn't it? I blew it right here. 23t. 23t. Okay? I'm plugging in a is equal to 5, b is equal to negative 23, and c is equal to 19. Okay? 23 plus or minus the square root of negative 23 squared minus 4 times 5 times 19 all over 2 times 5. Okay, that's going to give me 23 plus or minus 12.2 over 10, which gives me 23 plus 12.2 over 10, or 23 plus minus 12.2 over 10. and I will get 23 plus 12.2 divided by 10 is 3.5, so x is equal to 3.5, and I guess is in this meter, 23 minus 12.2, and I get 10.8 divided by 10, and that is 1.08, which would be 1.1, and it's asking when, so these are seconds. And obviously that's when it's first thrown, and this is when it's coming back down. Okay? When will it be 115 meters high? So there again, I'm going to plug in for h. 115 is equal to 23t minus 5t squared. 5t squared minus 23t plus 115 is equal to 0. When I plug it into the quadratic, I have a is equal to 5, b is equal to negative 23, c is equal to 115, and this one will be 23, is x is equal to 23 plus or minus the square root of negative 23 squared minus 4 times 5 times 115 all over 2 times 5. And when you do what's under the square root here, you will find that you get a negative 1771, which means your answer is what? Never. Okay? It will never reach 115 meters high. Okay? When will it come back to the ground? Okay, so ground is 0 is equal to 23t minus 5t squared. I'm going to pull a t because that's all they have in common. 0 is equal to t, 23 minus 5t. So t is equal to 0. Okay, or I've got 0 is equal to 23 minus 5t. Okay, I bring a 5t over. I've got positive 5t is equal to 23. Divide both sides by 5. And my t is going to be 23 divided by 5, which is 4.6 seconds. And obviously, when will it come back down is going to be the 4.6 seconds. It is not going to be the 0. That's when it left the ground. Okay? And your problems are going to be very, very similar to this. You're going to have to show all your work on a separate piece of paper. So take some paper, because obviously you're going to be doing a quadratic equation, at least, and doing equations for most of them. And have a nice day.